So hi, to those of you who are not here with us. We're going to be going over 2014 number 1. And if you were not in class, at this time I want to encourage you to grab a calculator, pause the video, and do this question. And we'll see you in 15 minutes. Welcome back. So, 2014 number 1 is one of the AB/BC crossover questions. There are 3 questions every year that are jointly given on the AB exam and BC exam so as to give some continuity and also so that the BC exam can receive an AB subscore. And this particular question was a classic kind of crossover question. It was a rate problem in which you have in this particular case, a quantity, and you have to do some ratesy kinds of things with the problem. So let's take a look at it. In part A, you are given an amount of grass clippings in pounds measured as modeled as 6.687 times 0.931 to the t power, where A is in pounds and T is in days. Find the average rate of change of A of T over the interval T between 0 and 30, indicate units of measure. I'm going to spell average rate of change as delta A over delta T. For A of 30 minus A of 0, all of that over 30 minus 0. And now remember that whenever we need to find function values or integrals or derivatives in the calculator section, we're going to use the calculator. And so we immediately grab the calculator and enter that A of t right into the calculator. Some students will actually do that ahead of time before they even start working on the problem, and I think that's a good idea. Notice that this pause is so that they can validate the software process. That's good stuff. All right, so we're going to let y equal 6.687 times 0.931 to the x power. Get rid of our extra junk. What is it? Get at it. Okay. Is that good? That looks good. Now, before I hit graph, what else do I need to do? Window size. Domain's easy. What's my domain? 0 to 30. What about the range here? For the range, I need to know something about the nature of my function. What kind of function am I looking at? Not logarithmic. Exponential. There you go. Gotta find the right one there. And it's going to be decreasing. That's right. So what's the largest value I can expect? The initial value. Let's call that 7. And what's the smallest value I can expect? 0. 0 to 7, and now we have a lovely curve. Okay. That took us a couple of seconds to do, but it's not too bad.
Could you plug in 30 to the equation?
Yeah, you can't just plug in 30. I like to do it like this because I know I'm going to need that curve for derivatives or integrals later, and then I can just use trace. So what you're considering is more efficient in the short term, but not in the long term. So now I do trace and 30, and that gets me the value of 0.7829 minus the initial value, which of course is 6.687, all over 30 minus 0, and that's going to be in the units of A divided by the units of T, days, pounds per day. Notice that I can leave this computation right here as I found it. If you choose to simplify this, then I got negative 0.1968, but there's a reason you might want to consider not simplifying this, and that is because of the potential for round-off errors. Here, they accepted, according to the key, they accepted anything in the range of negative 0.197 to negative 0.196. So anything that's in between those two numbers, which includes, of course, negative 0.1968, would be accepted. Right?
What if you just make negative 1.1974, since it rounds to 7 and that counts, right? That was 7.4.
Yeah, I think they would take that. In part B, now.
So how much?
Oh yes, just one.
Just one.
If they have the answer and the units. Right. Find the value of a prime of 15 and using correct units, interpret this. Finding the value of a prime of 15 is a simple matter of second calc dy dx. You do not have time to be taking derivatives by hand, and you also have no reason to. You are strongly encouraged to do all equation solving, value finding, derivative finding, integral finding directly with the calculator. And so we're going to do a derivative here at t equals 15. When we do, that comes out to negative 0.1636. And the units again are in pounds per day because I'm looking at a rate of change. Now we have to go to the interpretation. What three elements do I need in the interpretation? I need units, of course, yep. No, those are the magic words that I'm using. What are the magic words for interpreting a rate? Wow. That's very good. What does this negative sign tell me? Decreasing. Ah, those are the magic words indeed. I'm going to interpret every single positive rate as an increase in quantity and every single negative rate as a decrease in quantity. So, increasing or decreasing magic word, units, and what's the third element that I need? Time. The specific time. Yeah, the specific time that we're talking about. Or be specific, be specific. So here it is. We're going to put it all together. We're going to say the amount of grass. The amount of grass is what A represents. Is decreasing by 0.1636 pounds per day at t equals 15. And all three elements here are necessary to have.
What if I wrote so they're asking about what does the a prime of 15 mean? So I said the change of something t equals 15.
They were asking that question, and that's how you want to answer it. It might be the case that your grader would accept the rate of change, but they're asking you to interpret it in the context of the physical problem. So if you say something about A, then you're not telling us what A means in this problem. Right? So I cannot say A is decreasing by, and I can't say that this is the rate of change of A. I have to let them know that I understand that A is the amount of grass, the amount of grass is decreasing by. Yes,
You mentioned this value is the rate of change in the number of pounds of grass clippings at the time it was 15. There's no mention decreasing. I would think that
I am not sure. I have looked carefully through sample student responses and the commentary on them, and I have not found an instance where a student said that and was either accepted or dinged for it.
what is the thing you're saying for point?
What's that?
What is the point distribution?
So the way they did points here was they gave you 1 point for finding the value, and the value could be negative 0.164 or negative 0.163, and then 1 point for the interpretation. Given the point, write a nasty note. The magic words are increasing or decreasing.
It uses decomposing, so it's
Okay, that would be considered acceptable. What's that? Grass clippings. When you cut the grass, there will be pieces of grass left over. Right? They get all along my driveway. And I have to break them off. Yep. They're very picky about the wording for this. And for that reason, I kind of tell you the standard thing. Just use the standard thing. Make it a standard thing. You know what I'm saying? It may be that I'm being overly cautious. It may be that I'm being overly cautious about that, but I doubt it.
They actually use decomposing in the problem, that's why they use it.
Sure. Decomposing is perfectly fine. Rate of change of, unknown. I don't know whether or not they would consider that to be an acceptable demonstration of an understanding of the concept. Does that make sense? C, find the time for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the interval. In part, here in this question, they're asking you to distinguish between average rate of change in A and average amount in B. The average amount we construct as the total for A. Notice I don't need to give an equation. I can just say it's A of T. And if I want that to be equal to A of T at some time, then I have to set it equal. And then solve. This quantity over here, I can construct simply by finding the interval. And so here we go. Second calc and integrate. And we're going to integrate from 0 to 30. And that gives us a certain total grass clippingage over the total amount of time. So this is measured in grass clipping hours. And now if I divide that by the total amount of time, that will give me the average. Notice that this guy right here, as soon as we compute it, is copied into your answer. So the way that I computed it was to simply take answer and divide by 30. Did you know you could do that? There you go. And so that gives you your average, which is 2.7526 pounds of grass. And so now I want that to be equal to A of T. I already have A of T, so I can let Y2 equal to 0.7526 and find the intersection point. So one of the features of these questions is that if you are clever with your calculator, you can do these questions more quickly. That's one of the things that they're actually kind of incidentally testing. And that gets us T equals 12.4150 days. Notice that it's entirely possible to do this algebraically, like divide both sides by, no, don't mess with that. Second calc intercept. Okay?
So how much from this?
Oh yeah, so they do 1 point for constructing the average value, if they have 1/30th of integral from 0 to 30 of a of t, or anything equivalent to that, anywhere on their paper. And 1 point for the answer, which could be either 12.4 in 5 days or 12.4 in 4 days. Now in part D, they ask you to do a linear approximation of t equals 30. And since we are very comfortable with Taylor series, we'll put our linear approximation in the Taylor series form. So we recognize that it's going to just be a first degree Taylor polynomial centered at t equals 30. Ta-da. And we already have a value of a of 30, which we got in the previous thing. And we have a value for a, no, we don't have a value for 30. Let's get that down. So second, calc, and dy dx, 6. And that's going to give us, at t equals 30, 0.7829. No, that was wrong. Negative 0.0556. Okay, and this is our L of t, this is our local linear approximation. Let's get rid of our awkward false negative. And we want that to now be equal to 0.5 pounds of grass. And so we solve second calc intersect or what have you. Here is a weird thing that I don't fully understand and don't fully like. This is algebraically the answer. You can see how I got that, right? Subtract both sides, divide and fold. When I actually evaluated this, what I got was t is equal to 35.0518 days. That's what it is. Now in the answer key, when you take a look, they award points like this. You get 2 points for writing your local linear approximation, presumably 1 point for setting it up like this, and 1 point for having the right slope and point, something like so. You get 1 point for setting L of t equal to 0.5 right here. And then they get this answer, t equals 35.054, minus t equals 35.052. Yes?
What if I did like, without that information I did, I find the theorem that people can first. Minus, should I get one?
Well, is this the right equation in the end? Yeah, probably. Yeah, it is. Use point slope form. You've been stubborn about it.
I'm really used to you guys version for this.
Get used to it. It's Taylor polynomials. It's really straightforward. Stop being stubborn.
Notice that they put a 30, prime 30, once you like 6 figures.
Yes. Yes. That's what I wanted to observe about this. I want you to see something that I found. So with these numeric things, sometimes they'll accept a range of answers based upon rounding issues, right? So I thought, okay, maybe then they might accept 35.052, which is what I got, because I took these guys to 4 places in each case and did my computation based on that. Look at this. This is depressing. Here is the commentary on this answer right here. Okay, so this is answer 1 is perfect. Okay, here is answer number 2. And answer number 2 has some issues. That's the way they usually do this. And notice that here, this student does everything that we did. They have a derivative. Derivative is calculated by hand. And they set that equal to the slope. They get the slope just like we did, blah, 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 blah. And they get t equals 35.053, right? It's off by 1 in the 3rd decimal place. Commentary. Sample student score number 2. The student earned 6 points, 1 point in part A, blah, blah, blah. In part D, the student earned the first 2 points for LOT and the point for setting LOT equals 0.5. The student's answer is not accurate for decimal places. Up until this question, AP Philosophy had been, you get the right answer within plus or minus 0.001, you're good, which is why I make my students go 4 places, which isn't that kind of guarantee, right? In this particular case, the only way to get their answer is to keep extra places in both your derivative, especially your derivative, and also in the value of A30. What's the moral of that story? I don't know. Maybe the moral of the story for this is keep lots of extra places. Certainly that might in your intermediate calculations. Maybe the moral of the story is never simplify. I'm not really sure how to parse what they did there. I will also say this. Your score is not going to make or break based on a rounded issue. So don't obsess over too much. But also, keep some extra places in your intermediate calculations. I think that's the If you don't have 35.054, then apparently you don't get a vote.
For the sake of our quiz, though, it's never happened before.
For the sake of your quiz, we're going to do it like they did it.
I mean, we got it anyway.
Okay. I'll see you guys tomorrow.